All right, well, good afternoon, everyone out there in Facebook land. Welcome to our first Fullstack Academy Remote Immersive Demo Day. We're really excited. Yes, you can see me and Amri here, live broadcasting the event from Fullstack's beautiful New York City campus. And we're really excited to show you what everyone's been working on. This is the graduation of our first Fullstack Remote immersive class, and they've been working on some really crazy stuff. And by crazy, I mean good stuff. So I'm excited to have everyone see it and have everyone check out what they've been working on. And I'm going to kick this off to Omri, who's been their fearless leader and champion and instructor, and kick off the ceremonies. All right, Omri, off to you.
Thanks, David. Yeah, I'm really excited for today. We've got an awesome show lined up for you. We have 6 different student projects, 3 of them group projects, 3 of them solo projects, and at the end we've got 3 really awesome tech talks that students delivered while they were here. And they were so great, we just had to show them again as well. So let me just outline the agenda for anybody out there curious. So we're gonna have a code huddle giving their presentation. That's for 6 minutes. We're gonna have Byte Swipe coming up, and then Transcend Vrt. Each of those 6 minutes. These are the group capstone projects. We have 3 more projects after that. Stackathon projects that were done solo. 10,000 feet, 3D Game of Life, and Working Women Advocates. And then we have those 3 tech talks I mentioned: the future of VR, Node.js on the mainframe, and web workers. So to start us off, I am going to pass it off to Code Huddle. And I just want to say that this team has done an amazing job building something, and they'll tell you about it, but building something that we're going to keep using here at Fullstack, which is awesome. I love it when that happens. Code Huddle, you ready?
Yes, we are. All right, good afternoon, everybody. Thanks so much for being here with us today. My name is Evan, and with me are my good friends Amy, Amram, Andrew, and Sarabi. And together we are Team Code Huddle. We're here today to present to you an awesome web application that we built that helps potential web development candidates perform their technical whiteboarding interviews remotely. Code Huddle introduces a fully collaborative, real-time environment for both interviewer and candidate, complete with whiteboard and customizable text editor, and serves as the premier solution for remote technical interviews. So, if you will, imagine a scenario where we have a potential employer, let's call them Hobbs, and Hobbs wishes to perform a phone screen with a candidate, Calvin, who's located in a different city and thus is to be interviewed remotely. Hobbs wants to see if Calvin can implement a breadth-first search algorithm on a binary tree, which sounds like the perfect kind of problem that you could use the whiteboard on Code Huddle for. So now I'd like to hand it over to Sarabi to take a closer look at some of the things you can do in the interview room. Sarabi, take it away.
Thank you, Evan. So as we can see on the day of interview, Hobbs and Calvin are in the same interview room. Hobbs can see problem set, whereas Calvin cannot because he is a candidate. And now they start their interview by setting text editor options. They turn the linting off, they turn on gutter, they turn on text size, and they change the text editor theme. And it seems now Hobbs has explained problem to Calvin, and Calvin starts drawing tree on the whiteboard. And he draws traversal through the tree, selecting a new color from the color palette. And we can see that the same drawing is being drawn on Hobbs' screen as well. Now they move on to the text editor where Calvin writes pseudocode and then he writes the actual code. But it seems Hobbs finds a mistake in Calvin's code and he highlights it by selecting that portion of the code. And this was a feature request from our daily users of Code Huddle who are our classmates in our remote cohort. And this is how you could use whiteboard and text editor in our Code Huddle. And we have implemented whiteboard by using JavaScript library called React Canva. We use this library because elements like canvas and line, they can be implemented as actual React components where we can pass props to them. And the drawing that you see on whiteboard are actually a lot of Canva lines. And this is the actual implementation of React Canva in our application. For more features on Code Huddle, over to Amy.
Thanks, Sarabi. Here we see Hobbs' interviewer dashboard containing his list of upcoming interviews. Let's take a look at the interview details as an existing interview is edited. Among other items, Hobbs can add technical interview problems from his organization's stored problems. And that's the interview planning screen. In Code Huddle, we implemented our state with Redux store, where the data must remain immutable. A complex store containing arrays and nested objects requires a deep copy, which can be difficult to code and maintain correctly. Further, store complexity tends to grow as the application grows. For example, here's a small section of our Redux store. As you can see, it has multiple arrays and nested objects. The solution we found is to use immutable.js for the Redux store. As you can see from the code snippets here, immutable simplifies the code, making it more readable and thus easier to maintain. Additionally, immutable.js brings the advantage of more performant code. Immutable achieves this through structural sharing, more specifically, hashed array map trees. Copies are made only when data is actually mutated, and retrieval can be even faster than vanilla JS. Further, immutability means read-only data, which means the opportunity for concurrency without locking. And now on to Andrew, who's going to talk about application data flow.
Since Code Huddle is a real-time collaborative application, we had the task of keeping all the clients synced up with the latest interview data. To achieve this, we used Redux on the front end, Redux on the back end, and WebSockets via Socket.io to communicate among the clients. Here's a diagram of a typical data flow for a client action. On the top left, we have a client. And for example, let's pretend Calvin types q.push into the text editor. Since we want this action to be synced up, we tag it as remote is equal to true. Then the action is dispatched to its own local Redux store like normal. But we also have a sockets middleware for the Redux store that detects we want to send it to all of the other clients and sends the action to the back end. This is accomplished through a pub-sub relationship with sockets between the client and the server. The server dispatches the action locally to its own local store and then broadcasts the action to all of the other clients. The sockets middleware on all the other clients receives the action and dispatches it to their own local stores. And once all the stores are updated, the subscribing components will update and render on the application. Now off to Amram to talk about the technologies that we used.
Thank you, Andrew. So for our application, we used React, Redux, and Material UI on the front end. We used Node on the back end with an Express server and SQLize as our ORM. We also have testing for all our routes using Chai and Mocha. On the left side over here, you see a diagram which shows all the tables in our Postgres database. Our backend is written using the RESTful architectural pattern. And on the right side, you have all the endpoints in our API. And each one of those corresponds to a table in our database. In conclusion, our cohort has been using Code Huddle for the past week to solve remote programming challenges. And we've received lots of positive feedback how it really helps to simulate a whiteboarding environment. The Fullstack staff has notified us that they will be using our application in the next remote cohort. So we really hope you'll check out our application. It's available live on Heroku, and thanks for listening.
All right, thank you very much, Code Huddle. And thanks not only for the awesome presentation, but also thank you on behalf of the remote juniors that are rising now and are going to be using your tool during senior phase and the remote full stack community as it grows.
So Omri, I've done a lot of technical interviews, both as interviewer and interviewee, and we always have a lot of technical problems with the things that we're using. And I've never seen, although I'd love to, the power move of, oh, your interviewing system's not working, why don't we load mine up? So I hope to see that from some of the full stack remoters.
Yeah, that'd be awesome. And by the way, if anybody out there is curious about using Redux and Socket.io together, you should totally check out their code base. They've got something awesome going on with that socket middleware that Andrew was describing in the middle. Cool. So that's Code Huddle. Moving on here, I'm going to pass it off to ByteSwipe. ByteSwipe has solved a problem that we are all familiar with: wanting to eat and wanting to eat good food. They have a pretty fun take on it. I'll let them show you.
Omri. I'm just going to set up my screen share here. And here we go. Hi, thanks for joining us today. I'm Rachel with Team Run DMJ, and I'm joined by Dennis, Mark, and Joe, and we're bringing you ByteSwipe. So here's the struggle. We have Mary. She's fraught with indecision. There's so many great dining options near her, but she wants a fun way to find a spot to eat. And then we have Sam. He's bored. He's tired of all the restaurants around him. He wants new options. So that's where Bite Swipe comes in. You can swipe the restaurants near you and choose your favorites. You swipe left for what you don't like and right for what you do, like on Tinder, and you get a fun interface with plenty of pictures. So I'm going to show you that now. So we're going to have Mary swiping through our app, and she can click on one to get more information. So here she's getting restaurant information and reviews, and the pictures carousel across the top. And you can see here as she's swiping, her results are accruing in the top right. So she can go and check those out, delete what she doesn't like, then go look at the map. And she can click on a pin here to get more information about that restaurant. And we also want to highlight you can click the Yelp button to go right to the Yelp listing in your browser. So with that, I want to bring in Dennis to talk to you about how we built this in React Native.
Thanks, Rachel. So we decided to build this app using React Native since React Native lets us build a mobile application using the skills that we learned here at Fullstack. So I'm going to talk a little bit about React Native. It's a library maintained by Facebook and shares a lot of fundamental similarities to React while still compiling all the components down to platform-specific native UI components. And so the couple differences that we noticed during our work was that React Native has its own set of components as opposed to divs, we have views, and styling is a lot different. Instead of CSS, you use inline styling, and everything revolves around the idea of flexboxing to have things positioned on the screen. I think the biggest difference that we found during our time using React Native was that the workflow or the build environment was completely different. You had to have an emulator running as well as a remote debugger, and it took a lot getting used to. So in the beginning, we ended up seeing a lot of this, which is the red screen of death, and it's kind of hard to even tell what's going on. But essentially, after we got more familiar with React Native, we ended up getting something really awesome, an Android app and an iOS app at the same time. So now I'm going to talk a little bit about how our application flows. So when the user comes in, he's taken to this not logged in screen. He can either sign up or log in with OAuth. After that, he transitions to our main Bite Swipe screen, which has swipe view as well as results. And we actually end up persisting the user's information into local storage so that when he returns to the app, everything is exactly how he left it. And so from this screen on, we can also move to other screens. So the main navigation that we can do is to go to a single restaurant page that has tabs as well as a Yelp page and search settings, which has categories and additional categories. Now I'm going to bring in Mark to talk more about UX design.
Thanks, Dennis. So our team was really excited to build a mobile app because we knew that we could build one that would be attractive and intuitive to navigate and fun to play with. So we spent a lot of time up front talking about some of our designs and some of our layouts. We talked about what information exactly does the user need on this screen, because we want to give them enough information that they can make this very important decision without overwhelming them with too much stuff. So we spent a lot of time up front talking that through, and I'm glad that we did, because we came up with this card view, which I'm quite proud of. We actually had a lot of fun working on the styling. One of the nice things about React Native is that you can change styles and they update instantly. So that was kind of a treat to play with that. Here's another view. This is our restaurant detail view. So as I said, we had a lot of fun working through the layouts and making it fun to use. So here's a little bit about our architecture. Our story starts with Mary, who is hungry and doesn't know where to eat. So she's going to get out her phone. She's still logged in. And she will send her location from her device to our server, which will bundle that with her saved preferences and make a request to Yelp for a list of restaurants nearby. Now, our server is acting as a proxy here because of something with the Yelp token, which I'll let Joe talk about a little bit more. But before long, Yelp will come back with our list of restaurants that are near her and fit her tastes and are currently open. It'll then be filtered and sorted based on her swiping history from our database, and finally rendered to this card view where she can have fun swiping through local restaurants. So here's Joe to talk a little bit about some of the problems we overcame.
So like Mark said, I'm going to talk about some of the technical problems we faced and solved. The first big technical problem we had was with the request token. So when a user logs into Yelp, they get a request token and they can make a request to Yelp to get restaurants back. But after 6 hours, that token expires. We added functionality into ByteSwipe that would allow us to automatically get a token back so that a user could make as many requests as they wanted to. Another problem we had to deal with was with filtering. We had to design the filter setting page around the 100 different categories that Yelp gives us. So we split it into 3 different pages, and we had to manage the state between each one to be able to get it to function all as one thing. And then we hope to eventually add in a setting in ByteSwipe that will allow friends to compare result sets.
We encourage you all to check out ByteSwipe and download it at byteswipe.herokuapp.com. You can just click on the download for Android button and it'll download to any Android device you have. So thanks so much for watching, and we hope you enjoy using ByteSwipe.
All right, yeah, thanks, ByteSwipe team. I want to say, I don't know if anybody out there right now has tried to use React Native before. I know I have, and it did not go well. I've been really impressed that this team managed to pick up React Native and make something not only working, but really awesome in like that short 2-week period building this project. Yeah.
Yeah, that's pretty crazy. I think, and they also tackled a problem that I've heard many people talk about. My solution to that has always been just recommending the worst place possible, then everyone will jump in with better recommendations. But now I have an app that I can download and make everyone else download to tackle this lunchtime dilemma. All right, great work, ByteSwipe.
Yeah, awesome. Up next, we have a Transcend VR team. I don't want to say too much. I think the demo is a lot of fun, but it's a new kind of social experience and classroom experience. So Transcend, take us away. Take us up.
And I was muted. Good afternoon, everyone. I'm Sean, and Joey, Una, Beth, and I are here to tell you about Transcend, the VR classroom experience. The 4 of us are members of Fullstack Academy's very first ever fully remote cohort. We experienced the same challenging curriculum as our on-campus peers, but our lack of a shared physical space has made it harder for us to bond and build friendships. Our project fills this gap by building the world's first ever virtual reality classroom fully powered by open web technologies. Between a 2015 Pew Research survey that suggests millennials are increasingly willing to make friends virtually over the internet, and psychological research that suggests humans experience space in VR very similar to the physical world, we believe that Classroom VR has the potential to add a new level of immersion to remote education. And now I'd like to hand things off to our Chief Happiness Engineer, Una, to show you Transcend.
Thanks, Sean. So for today's demo, we're going to be focusing on the browser view, but we do have beta support for the Daydream headset for anyone who's interested. So right now we have our instructor, Omri, log into the Transcend app. When he first logs in, he'll be spawned into the main room. Here he can roam around using his WASD or arrow key controls. We also implemented peer-to-peer audio so he can speak with other players in the same room in real time. One of the things that Omri can do is also pick his avatar skin. He can do that at the gap. In order to switch between rooms, he can simply place his cursor over the orb for 1 second or click on it. Now that he's in the room, he sees a wide selection of costumes to pick from. We see here Sean also picking a costume for himself. Today, Omri will go with Admiral Grace Hopper. Now that he has his costume picked out, he's going to return back to the lobby where a few students are talking, but he'll see Danny, whom he'll want to speak with in private.
Properly plugged into the wall.
Is there electricity flowing?
Well, hey, it's a little loud in here. You want to go to the cat room?
Yeah, definitely.
Do you have the proper drivers installed for your monitor?
Wow, this is an amazing room.
Ah.
Wow.
Anyways, I just wanted to talk about my favorite students. Do you know who they are?
Oh, no, I don't.
Well, there's Una, Beth, Sean, and Joey.
Yeah, I totally agree. They're pretty great.
I know. Well, I'm glad we're on the same page about this. We can head back to the lobby now.
Cool. See you there.
Now that Omri's expressed everything that's on his mind, he'll log out for the day. Now I'll pass it on to Joey, who'll talk about some of the technologies we used and some problems that we faced.
Thanks, Una. One of the main technologies we used throughout our project was Redux on both the front and back end. Our backend Redux state serves as our centralized source of truth for all users. It holds user data, which rooms users are in, and where the users are positioned in the world. When a user executes an action, it is stored in the user's local Redux state, then emitted through a socket connection to the backend. The backend updates the global state and emits the changes to all of the users so they can update their view. On the front end, we used A-Frame to render our 3D scenes. A-Frame is a relatively new WebVR technology driven by Mozilla. It's built on top of WebGL and 3JS and allows 3D entities to be written straight onto the DOM as HTML elements. We faced several race conditions with A-Frame where we were trying to add users before our scene was loaded. We fixed this issue by bouncing socket events off the backend when the scene was loaded before receiving user information. This forced the user to render the other users on the DOM before updating their position on the tick. Another major technology we use to establish voice communication is Webrtc and peer-to-peer connections. So when a user connects to a new room, they send an offer to the backend for a new peer connection. The backend then emits this to all of the users in the room who reply with an answer. When the new user receives all of the answers, a new peer-to-peer connection is established between the user and the other members of the chat room, thus allowing real-time voice communication to be achieved. Let me hand it off to Beth to discuss other technologies and problems we faced.
Thanks, Joey. One of our main sources of both fun and frustration throughout the project, like Joey said, is that A-Frame is relatively new. When we created Transcend, it was only on version 0.4, so there were still a lot of inherent bugs, and there was a lack of documentation for some of the more complicated features. We had several conversations with core contributors who were sometimes just as puzzled as we were by issues we were facing, as the Slack conversation shows. In addition, rendering A-Frame elements with React is still relatively untested, and they didn't necessarily play nice with each other. They're fundamentally based on different programming paradigms, and both had their quirks as to what they liked and accepted about the other. For example, height and width are reserved words in React, and so we couldn't render native A-Frame entities like A boxes, as you see in the first code snippet. Instead, we had to render them in a more 3JS-like fashion. We attempted to use a raycaster to detect intersections with the ground to enable teleportation in the Daydream headset. In conjunction with the number of 3D elements we were rendering, we ended up hitting the limits of what a mobile browser could do. So we needed to find a way to optimize. And to do that, we ended up turning on the raycaster only when you click the controller instead of having it always on. Lastly, one of our other primary challenges was link traversal. Chrome security issues mean we're unable to use a lot of WebVR APIs, including hyperlinks. We found that pure hyperlinks to get a user from scene to scene would knock the user out of VR mode, which isn't what we want at all. And so our teleporter orbs are essentially React router links, where clicking a link clears the DOM, renders a new room component within the same ascene tag.
Thank you, Beth. On this slide, you'll find our GitHub project. Stars are appreciated, issues are encouraged, and forks are welcome. Our project is also hosted live on Heroku. Feel free to join, make friends, and be good to each other. Thank you very much.
Thank you very much, Transcend team. Stellar job. Really cool app.
Yeah, I mean, I gotta say, you got React in there, you got A-Frame, you got Webrtc, you got the Google headset stuff.
Yeah, it's a
one thing.
What is that? What's the word for that? Buzzword bingo. I think they won buzzword bingo here.
Yeah, they got a lot of buzzwords in there. One thing I didn't understand though is why you make people shop at the Gap, but some technical things we'll just, leave for another time. But that was very impressive. That it looks a little bit like the Fullstack campus. I think I love the Fullstack box with the two monitors on top and the whole 1984 gallery view that they had in the big room. And we actually do have a cat room like that on campus. It's staff only though. All right, great work.
Yeah, so those are the three capstone projects that got worked on. The next coming up, we have 3 stackathon presentations, 4 minutes each. So these projects were done solo by the students that are going to be presenting, the engineers that are going to be presenting, and they were all prize winners from our stackathon that we host here at Fullstack. It's about a 3 or 4 day affair. So these projects were put together really fast, and they're very impressive. So up first, I'm going to introduce Andrew with 10,000 feet. Hopefully, I'll start using this app soon, and maybe I'll get in shape, but I doubt it.
All right, thanks, Amri. So hello, everyone. I'm Andrew Garcia, and for my Stackathon project, I built an application called 10,000 Feet. And this application was built for developers to help them become more cognizant of their coding activity as well as their physical activity, and to see if there's any imbalance between getting the right amount of steps per day versus keeping our coding skills sharp. So there are numerous studies out there that outline how sitting, which is an unfortunate part of most of our days as developers, can cause all sorts of problems. So this application aims to bring awareness to the developer. To get both sets of data, this application leverages the Walk-A-Time and Jawbone APIs. So here's the application's main splash page, and we can log in on the top right here. And then we'll authenticate using up. And here's the main dashboard of the application. There's a card for each of the past 7 days' activity. But let's focus on Monday's activity. So the x-axis here shows the time throughout the day. It starts from 6 a.m. and goes till midnight. And your coding activity is represented through these blue rectangles. For instance, from 2 to 2:30, I can see what project I worked on and for how long. And also, your physical activity is shown through the orange line, so you can see your fluctuations in physical activity throughout the day. And also, if you want more details, you can click the Details button. And here on this page, you have the same graph up top that shows all of your activity, but you also have your daily goal progress. So I have my goals set for a target of 5 hours for coding activity and a total of 10,000 steps for my physical activity. And then at the bottom, you have a list of what projects that you worked on for that day and how long you've worked on them for. And I also wanted to provide a visual reminder throughout the day to remind the developer how much of their goal they reached for that day. So I programmed an Arduino that runs Node and pings my application API for health and coding data. The Arduino commands the brightness of a set of LEDs according to how much of your goal you met. So as you walk and as you code throughout the day, the LEDs will dim more, and the goal is to have them completely dim by the end of the day. And as far as technologies for the application, the web app was built with Node, Express, React, Redux, and D3 for the graphs. And the Arduino was programmed with Node and the Johnny 5 library. So you can check out my projects on GitHub. Thank you all for listening, and that is 10,000 feet.
Thanks, Andrew. I was noticing that you walked about 7,700 feet a couple days ago. That sounds pretty impressive. I think I get about 1,000 steps in maybe a day.
So I'm a big believer in this 10,000 thing. So first thing I did was I bought a standing desk. Then I bought a treadmill for my standing desk. And then, much to my shame, I bought a chair that goes on top of my treadmill that I use with my standing desk. So that's kind of what the current state of affairs I'm at. I need this desperately.
Cool. So up next we have, we have Mark presenting his 3D game of life. This was a really cool project where he took the ordinary game of life and took it to the next dimension. Mark, you ready?
Yes, I am. Thank you, Omri. Let me go ahead and share my screen. So, as Omri told you, I built the 3D game of life for our Stackathon project at Fullstack. So, as a quick reminder, I wanted to show people what the game of life was, just as a refresher. So, this is the game of life. It's essentially a two-dimensional grid of cells, which are either alive or dead. And based on the number of living neighbors to a cell, the cell will either die or stay alive the next round, or it will be reborn with the correct number of living neighbors. So here's just a simulation running. You see it looks somewhat lifelike, basically like a sort of a colony of bacteria. And it's pretty interesting. I've spent quite a bit of time just kind of watching this. It's a little bit addictive. So the cool thing about this, though, is that with these very simple rules, we actually have some pretty interesting animations that can happen. So I'll go ahead and play over here. So these these patterns will continue indefinitely. I think my favorite is the top right because it looks like two clapping hands. But there's all kinds of different patterns, and there's actually some gliders, which is another one that I'll show you. So this is a pattern that repeats indefinitely while also moving across the screen. So those are kind of cool. And then one more I wanted to show you was this is actually called a glider gun. So this will produce those gliders indefinitely. And it's really interesting because with such a simple set of rules, we get such complicated behavior. So what I wanted to do was rebuild this in 3 dimensions. And so that is what I did. This uses Three.js to drive the graphics. And you can see this looks very familiar with what we were just looking at. Obviously, the gliders and repeating patterns are not statistically likely. So this is more of the random generation. But it looks essentially lifelike. And it's been a lot of fun to put this together. So one of the things I noticed when I was putting this together was that there are actually a number of different people that have built similar projects. And they all have different requirements as far as the numbers of living neighbors. So what I did was built this as a tool. Okay. So you can actually determine what those rules might be. And you'll notice if you look closely that the behavior actually will change significantly. And with some rules there are gliders and with some there are not. And so that's kind of interesting. And this toy here, it's actually pretty fun to play with, and it lets you try all these rules freely. So this is hosted on Heroku. Let me switch it back over here for a second. Those actually are the rules, as I said, very simple. This is currently hosted on Heroku. I would encourage you to go give it a try, have some fun with it, right? It's also up on GitHub, so I'd encourage you to check that out. And thank you for your time. I appreciate you tuning in today.
Thanks a lot, Mark. I'm looking forward to the undoubted sequel, next cohort 40 Game of Life. Although, I don't know, maybe I'm already doing that. Maybe that's what I am.
Well, Omri, what a lot of people out there on the internet don't know is that if you set it to 4 neighbors, 3 survivals, and 2 to stay the same state, what actually happens is that out of that will emerge a picture of my face. So I'll be willing to try that out in Game of Life 3D.
Wow, the secret of David Yang has been exposed. This is where he came from originally. A Game of Life simulation. That explains a lot. I won't go into the details, but it does explain a lot. Yeah, thanks a lot, Mark. We've got another really cool Stackathon project coming up here. Rachel's going to talk about an app that she built. One of the things I love about this is it's not only a very usable, wonderful application with a lot of excellent visual features, and it's well built on the inside. It's actually solving a problem that I think a lot of people out there could really benefit from. So that's incredible. So take it away, Rachel.
Thanks, Omri. So here's Working Women Advocates, and I built this for women experiencing issues in the workplace so they could connect with advocates who provide support and guidance. So here's a list of some of the issues women face at work. So advocates can help them out with that. But what I was really surprised about was that something like this didn't already exist, or at least it wasn't easily found through a Google search. Not even a helpline. Omri helped me find one, but it was down. So that was incredible to learn. This is where a woman would go to connect with an advocate. So she could just put in any username to be referred by to protect her anonymity. So I'm going to use Madonna today. And she can use this form for her preferred method of contact, and there are 5 different options, and the form changes based on the data needed for that option. So we have email, phone, text, and even other, just to capture anything that might work best for her. But today we're going to do Skype. And then we'll submit that form. Also, I have a form for volunteers. So they can say if they'd like to become advocates, and they can be vetted and see if they'd be a good match for the program. So RBG wants to be one. Let's log in to see what it looks like to log in as an advocate. So this is one of my best advocates, Michelle. And she can see the open cases, so she can take these cases on. She's currently working these cases, so she can keep notes and whatnot here. But I really like that the view changes, so you can tell you're logged in, and it's way more utilitarian, but still nice now. And the nav and the drawer change accordingly. So we're going to go ahead and log out, and we'll come back in as an administrator. So I am an administrator. So I'm going to go ahead and log in and see I get more options here. So I can see all the cases, and I can reassign people or view detail or close them. I can see all the advocates. I can, oh wait, I think right here, you can see Madonna that I just added. And you can see RBG that I added just now. And again, the nav and the drawer change. So that was fun for me because I have a background in Rails and Bootstrap. So I used material design here, and I built this in JavaScript. So I used Node, Express, and Sequelize on the back end, and React and Redux on the front. So I had a really good time with that. And the other good news I have is that people have showed interest in making this for real with me. So I have some volunteers to help build it out, and I'm hoping to make it into a nonprofit. So thanks for watching. And you can check it out on workingwomenadvocates.herokuapp.com. Bye.
Yeah, thanks a lot, Rachel. Yeah, that's really awesome.
That was a really cool project. I love stuff like that can have use cases that real people can use. I don't say this a lot, but one of the things I love about Fullstack is that some people who have backgrounds in other things come in and learn how to code and then build things that are useful for so many people that kind of engineers wouldn't necessarily see. So yeah, I'd love to see that on the real world. That's great work, Rachel.
Excellent. So from here, we're going to switch gears once again. Those are the end of the project demos. And now what we've got lined up are some really awesome Stackathon projects. Some really awesome tech talks is what I meant to say. So we've got 3 of those coming up, each 10 minutes long. And starting us off is going to be the future of virtual reality. Joey, why don't you take it away?
Thank you, Omri. Let me share my screen real fast. Hello, everyone. My name is Joey Derbyshire, and today I want to discuss with you problems and things that reflect fun when you're developing in virtual reality versus other normal web applications. So first thing we're going to be talking about will be unique problems to virtual reality itself, as well as concepts to consider in virtual reality that you wouldn't normally think about when you're developing web applications, solutions to both of those issues, as well as anything I'd possibly go on a tangent about while we're discussing this. So I have a lot to discuss and not a lot of time to talk about, so I'm going to jump right into it. The first thing I want to talk about is the distinct lack of peripherals, or as I like to put it, where are my buttons? If you don't know who this is, it's a comedian by the name of Brent Morin. He's got a Netflix special. I think he's hilarious. It's one of my favorite jokes from him. Go watch him if you haven't seen it. So what do I mean by where are my buttons? So let's look at modern VR headsets. So we have the Daydream, right? And the Daydream controller has 5 buttons on it total. 2 of those are specifically for volume, whereas the other 3 are probably the only 3 you'll be able to use for your application. You have things like the HTC Vive, the Oculus Rift, which have about 15 to 18 buttons and a joystick. The PlayStation VR uses the PS4 controller or the PS Move controller, which has about 18 to 2 buttons. That's a bit, but that's not a lot when you think about things like even just your TV remote, which just controls your TV, has 50 plus buttons on it sometimes, or a keyboard and mouse has about 900 million buttons on it in any given situation. To put this in perspective, this is a game I play pretty regularly called Final Fantasy XIV. Every one of these squares down here at the bottom, and on here on the right, represents an action or an ability that I can do in the game. And each one of them has its own unique button combination to it. So my mouse has about 17 buttons on it. I have 3 keyboard modifiers for it. I have WASD. I have various other keyboard inputs for menu controls, all that. Altogether, I have about 80 different button combinations just to play one game. So how am I possibly supposed to interact with a virtual reality game that only has 3 buttons like a Daydream controller does? So one of the first solutions you could really think about doing is displaying an on-screen keyboard. And this is something that consoles have done for a really long time. They'll just display the keyboard, you select the letters and type it out. It's very slow, but it's very effective. Things like searching or just inputting short commands or whatever. But it's not ideal if you wanted to write a program like Slack in virtual reality. How am I supposed to type out long messages to my teammates if I have to select each letter individually? That could take forever. So another way to go about it would be triggers, right? The game I mentioned earlier, Final Fantasy XIV, has a version on the PlayStation 4, which I said has about 18 buttons on the controller. So the way they do it is they have 4 buttons on the controller, which are dictated as triggers. And whenever you're pressing any of those triggers, it changes what the other buttons of the controller does. It allows you to get a wider variety of button combinations in order to gain different controls over your application. That's great and all, but you have to remember virtual reality adds something new. It adds motion to the mix. So you can start using things like your arm raising, your head moving from side to side. All these things add to a new gesture system that will allow you to interact with your application that we haven't seen before in our web development. If you look over here, you see what would be the 2-dimensional gesture system that most people already use on their smartphones, right? So imagine taking that to the 3rd dimension. You could start doing more like arm reaching and stuff like that. You could implement things like sign language or something like A, B, C, like just simple like that would really make it easier to type in a virtual reality environment that we just couldn't do in web applications normally. So that being said, I'm going to move on to the next thing, which is when you're developing VR, you need to stop thinking in windows and start thinking in rooms. So windows are this big convention we've had for the past 20 or 30 years where everything has its own box, everything stacks on top of itself. It works very nicely for computers, for smartphones, for everything that we use in our daily lives now because they all exist on 2-dimensional surfaces. In virtual reality, you have a 3rd dimension, and users, without even knowing it, are going to expect you to use that 3rd dimension. They're going to require you to reach out and make that 3rd dimension useful to them, or else there's no reason for them to even be in your VR application. Because if they can just view it on their computer, why would they view it in VR? So I'm going to give you 2 examples of applications that I think one does it well and one does it poorly. So the first one here is the YouTube app for the Daydream. If you've never seen this application, the way it works is you're in a large black domed room. Floating in front of you is a floating screen or a window where you access your searches, where you access your controls for your video. If you're watching a 2D video, it's just displayed there as a floating window. If you look around here on the sides over here while you're looking at this is all just empty space. There's nothing there. If you're watching a 360-degree video, though, it's very immersive because it fills up the whole dome, right? The whole dome just surrounds you with 360 video, and that's really nice. But on the other hand, you have things like the Netflix app, where whenever you're going to view it, you're sitting in this cabin that's on the mountainside. Over here, there's like a large window where you can see out into the mountains. You got posters on the wall that display like current shows that are popular on Netflix. There's furnishings around. This TV is quite a bit larger in the actual application, about this big. When you go to select a movie, the lights dim down. It feels very much like you're sitting in your own living room watching your own TV. It's a very immersive environment. But all that being said, 2D video is probably the worst example I could give for a VR application. 2D video just doesn't work in virtual reality because of the idea that it is in fact 2-dimensional, and we're trying to build in a 3rd dimension here. So really trying to think more outside the box when you're developing applications. How can I extend my application to the 3rd dimension? How could I make something that's more useful in 3 dimensions, like a 3D modeling program where you start out with a block and you chip away at the block to shape out a stool or something, where then you could export that stool as a 3D model and use it in other programs. Like, these are more ideal for what a 3D environment would use. So let me move on to my next point, which is immersion. So what is immersion? Immersion is this concept that's been really popular in games for a really long time, but it's something that's really going to start taking off more in application development when VR comes in. Immersion is the idea that the user feels involved with your application. They feel engaged in the story. They feel like like they're a part of it, as opposed to feeling disconnected or understanding that this is just a computer screen or whatever. So one example I think of really good immersion is Fallout, the Fallout universe, and the Pip-Boy. And if you've never played Fallout, it's this game series that's based in a post-nuclear warland. It kind of takes these old concepts of like ideas from the 20s and 30s and gives them new technological looks, very steampunky kind of ideas. And if you've ever played Fallout, you're very familiar with the Pip-Boy, The Pip-Boy is this large bracelet that the main character of the series will wear on their wrist. And every time they want to check their stats, check their items, change the settings in their menu, the main character will lift up their arm and look at their arm, look at this Pip-Boy in order to do all that. And it feels very a part of the world. It feels like it's very built into the environment. It doesn't feel like, oh, I just opened a menu and now I've just broken my immersion from the game. I still feel like I'm engaged as the character of Fallout. And I think that's a great example of how you could use immersion in a VR experience as well. So what creates immersion for a user? So the main things are your 5 senses, right? And the 2 big ones that you're going to see in VR are going to be sight and sound. Sight is obviously huge. It's the whole reason we even have headsets, so you can see the world around you. But sound is also going to play a large part in that going forward. So what's the 2 big ways that we currently use sound, right? So currently we see stereo sound, which is a left and a right channel. And then every time you play a sound, it plays at varying level volumes of left and right in order to give the user the feeling like the sound is around them as opposed to just playing from the speakers. And you also have what's called surround sound, which is either 4 or 5 speakers and a subwoofer, and it gives you a more directional sound feeling. So my headset is actually Dolby 5.1. It is surround sound. So if I hear a sound coming from back there in my game, it actually sounds like it's coming from back there. It's more immersive, and it's definitely better, but it's still, you can still just tell it's synthetic sound. It's not perfect, right? So when it comes to VR, this concept that's been around for a long time called binaural audio is really starting to take off because of how immersive it can actually be. If you've never heard of binaural audio, it's recorded with this funny looking mic that looks like an ear for the reasoning that the ear is already really good at shaping sound in a way that the brain can understand distance and direction. So why don't we record sound in the same way? That way they only need a left and a right channel. You could play those left and right channels straight into the ear, and it just sounds like your ear has picked it up from around you, and it sounds very immersive. At the end of my demo, I'll have links to several videos that this show or play binaural audio, so you can listen to it. And let me tell you, it really does sound like it's right there. It's insane, actually, the difference. Moving on. So the other big thing you have to be aware of when you're developing as far as immersion is spatial awareness. This is a situation where your user is actually too immersed into your application and they forget that they still exist in the real world. This is a situation where the user accidentally punches their monitor or bashes their leg against the coffee table because they forget that, oh, I'm not in this VR world. I'm still here. I'm still a real person. So you have to be really careful when you're developing your gestures or developing your actions that the user doesn't go and hurt themselves or break things, because they'll be upset with not only themselves, but with you as a designer for making those choices. So really be careful. But at the end of the day, you have to remember that I'm not an expert, but nor is anyone else in this topic. VR is still in its baby stages. These are the points where conventions are going to start being established. We're going to start setting trends that are going to be norms for the next 20, 30, 50 years in VR, and feel free to experiment with it. Remember that there are still problems with VR. People still find it to be very tech demo-y, very gimmicky. So remember that function is still king over form. So don't include things just for the sake of including them. Make sure you have a reason for including everything in your application and make sure it all flows nicely. I'll leave you with this quote that any sufficiently advanced technology is indistinguishable from magic. This is the reality that virtual reality is this new universe that you get to create. You get to set all the rules for it. You get to set what it looks like, how the user interacts with it, everything. So have some fun with it. Be creative with it. It's very, very powerful what we can do with virtual reality if we do it right. Here's some links to cool things I found while I was making this, as well as my capstone project, which was a VR project that I did. Thank you very much for your time.
Thanks a lot, Joey. Yeah, anybody listening out there, if you ever want to nerd out about virtual reality, Joey is absolutely the person to reach out to. He has a lot of amazing ideas, and it's just great to have discussions with him about this stuff. And you can also nerd out about Ready Player One if you've read that out there. Cool. Awesome. So up next we have Node.js on the mainframe. I absolutely love this talk that Sean's about to give. I'm just going to let him jump right into it. I think you'll all have a fun ride here.
Awesome. Thank you, Omri. So my talk today is really about JavaScript on and around the IBM mainframe. Might sound a little intimidating, but at the end of the day, it's not really about the mainframe. It's about the process of writing JavaScript and applying it to an unfamiliar environment. So this is really the synthesis of two talks, my tech talk on Node.js on the mainframe, and also Key Punch, my Stackathon project, which extends additional JavaScript efforts to the client side that interact with the mainframe. So the original Node.js talk was 2 demos, and now we have the Electron thing, and that brings us to a trilogy. And you know, when I think about trilogies and what my favorite trilogy is, one thing in particular comes to mind, and that's the original Star Wars trilogy. So I'm going to kind of structure this and take it forward. We're going to have a little brief prequel and then move on to the 3 main demos here. So the first one, mainframes are like Death Stars. And I kind of say that with tongue in cheek because it's kind of a ridiculous statement, but I think there's a couple of things there. So one central idea about mainframes is the idea of centralization. And one idea about Death Stars is the centralization of galactic power. So who kind of builds these things? I mean, it could be large galactic empires. It could be large Fortune 1000 corporations. Those are the kinds of things that might have Death Stars / mainframes. Once you build this thing, it's really powerful compared to other alternatives. And just a couple other things, long predicted to be obsolete, but thanks to IBM / J.J. Abrams, we keep getting rehashes of the existing stuff with new names, like Starkiller Base. Downtime can be catastrophic, resulting in painful changes of management. And once you're in the trenches, it can be difficult to navigate. Sometimes you gotta use the force. Okay, so now we're on to episode 4, A New Hope for Productivity, and I'm going to talk about Key Punch, the very first lightweight text editor built with the mainframe in mind. At the bottom, you can see my GitHub link if you are interested in checking it out. Okay, so here is my deployment architecture. You can see the data moving through the internet from my client to the mainframe system, and this just signifies that there's a lot of latency between my JavaScript program and all the mainframe stuff because we're running Electron. No surprises there. Okay, let's actually demo the thing. Let's punch it, Chewy. So here we are on the actual application. I put my user credentials in. Now I'm going to connect to the mainframe. I'd also like to show you that I've got light and dark themes. I always go with the dark theme, not the dark side though. On the left side, I've got a variety of detailed SVG icons that I handcrafted artisanally. And now I'd like to just open up a IBM mainframe job control language file. This just basically gives instructions for how a mainframe should do some sort of computing input with a batch job. All we're going to do is take this text here, pass it in, and then have the mainframe print it back out to us. So it's kind of like, you know, an echo command or something like that. So Fullstack graduation so close I can taste it. Congratulations to everyone, by the way. And let's go ahead and send this off for mainframe batch processing. Okay, that's quick and it's off. So let's go ahead and look at the output then. I've got a job number that the mainframe automatically assigns, and I can just go ahead and click download to get the report. Pretty big, so I'll zoom out here. One thing I want to point out is if you look at line 14, you'll see 17 cards read, and that's because the file that we sent in actually was turned into virtual IBM punch cards, just like in the olden days. So if we scroll down to the bottom, we will actually see the output on line 61. Graduation so close I can taste it. Okay, I've got one other feature, and that's basically a file browser for files on the mainframe. In mainframe land, they call it data sets. It's kind of structured a lot differently than most computers we're used to. But I've got a file on there that just has some kind of meta information about this application. We don't have time to go through it, but if you come back to this video and pause it, you can check it out. The thing I do want to point out is at the very bottom, I've got special thanks to Fred Bader and Marcel Mitron, two excellent IBMers that helped me get a lot of this stuff kind of set up and get systems access, which is, probably the hardest thing to do when you're developing stuff against mainframes. Okay, so now we're on to episode 5, Enterprise Linux Strikes Back. For this particular project, I took Juke, which is a Spotify clone. That's one of the final projects that we do during the junior phase at Fullstack Academy. And I went ahead and I ported that to Linux on the mainframe. It took about a day and a half to do, and I just like to show that. Okay, so here's kind of the deployment architecture. You can see Node.js running on Linux on the physical mainframe, and it's running under a common hypervisor, and that provides pretty low latency access. So we kind of bounce back and forth, and we have pretty easy access to the existing mainframe assets, but we're on a common kind of Linux environment that we're used to. And so let's go ahead and show the example. There's Darth Vader wearing a red hat because we're hitting Red Hat Linux. There you go. Okay, so first what I'd like to do is run a script that I wrote which generates a report, and that's just going to prove that we are on a mainframe here. If you look, you can see architecture S390X and then byte order big endian. For the aspiring computer science out there, you might want to check out what little endian versus big endian means. It's kind of an interesting side note. And then let's get this thing started. Okay. Looking good. Let's switch over to the browser here in a second. And here we are. This is Juke. So it looks very similar to Spotify. We have different albums and things. And I just want to prove that the audio actually works. Hopefully you'll all hear this. And we have different artists and type ahead, search, all that good stuff. This is probably my favorite project during the course. Okay, so now we're on to episode 6, Return of the Mainframe Jedi. And, this is kind of the most intense and serious part of working on a mainframe ZOS, an operating system that dates back to the 1960s. And so when you work with ZOS, you need to be ready to put on your hard hat. Okay, so let's get started. For this particular application, I've got a very simple Node.js application I wrote, and I'll basically just be showing that. But first, I want to go a little bit into the architecture of how this is hosted. Okay, so now instead of running on Linux, we are running under a Unix subsystem under ZOS. And so latency is even less, and then we have a lot of access to compatibility systems, which you'll see in just a moment. So we bounce our data flow through ZOS, and that gives us access to something really cool called the ZOS Language Environment Library, which I'm hoping that IBM is going to implement as a native extension. So by flowing through that, we hit C++ code that gives us very low-level access to all of these legacy mainframe environments, which allows some really cool opportunities for adding real-time internet enabling kind of stuff on top of existing corporate applications. So now I'm going to go ahead and demo the final program here. You're going to witness the firepower of this fully armed and operational computing platform. Get ready. Okay, so here we are in Unix. I'm going to just go ahead and generate another report very similar to the Linux one. This has a little bit less information because I don't really know all the commands here. So we got ZOS 2.2 and we've got Node.js 0.12, which is 4 years old. So this is a fully experimental Node.js version here, totally unsupported, not production ready. And finally, we'll just start it up. I've got some different word art, and basically you select your own kind of choose your own adventure things. It's got some mainframe inside jokes. I hope a couple of my IBM coworkers that I invited are out here so someone can appreciate these mainframe inside jokes. I select different subsystems and basically just describes what the different subsystems do. I think probably this is the last one. Yep, okay, game over. So closing thoughts, we live in the golden age of development. We are really not limited by things like access to knowledge or access to tools because of things like open source and resources like Fullstack. And so we are really only limited by our imaginations with what we kind of focus our attention on. And JavaScript is really associated with startup culture, a lot of things like that. And it's a really cool application, but at the end of the day, I think JavaScript is really the ultimate duct tape programming language. That used to be Perl, and I think that's JavaScript. And so we can apply that to things like startups, but we can also apply it to things in the long tail of enterprise IT if you want also. So I challenge you all to think outside of the browser and come up with cool and interesting hacks with your new JavaScript skills. Thank you all. If you are confused or anything, you can feel free to hit me in the comments on Facebook or any other way you want to reach out to me. I've got some additional information about mainframes and stuff there. Thank you all. Have a great day.
That was very impressive. I can't tell what's more hipster, someone talking about using 80 billion buttons in a VR multi-room situation, or someone running Node.js on a mainframe. I feel like if Sean was talking to Joey, he would say something like, back in my day, we didn't have rooms, we didn't have keyboards, we didn't even have more than 80 lines on a terminal screen, and you're complaining about, raycasting buttons. So very cool. I'm very, very blown away by that. The fact that even works.
I want to say I'm looking forward to your upcoming prequel or sequel talk that I assume, episode 7 of Star Wars is out, so you need a corresponding part of your talk for that. Cool. So from here, we're going to go to our final show of the day. We have Surabhi, who's going to be talking about parallel JavaScript in the browser and how amazing that can be. So Surabhi, why don't you take us away?
Thank you, Amri. Hello everyone, this is Surabhi Nigam, and I'm going to talk about web workers. This is an overview of my talk. First, I'll be talking what web workers are, then why do we need them. Then there'll be a small demo, and then behind the scenes how web workers work. Then web workers in JavaScript frameworks today, and then finally the references. So this dialog, I'm sure everybody must have seen this dialog once or twice or maybe every day in their lives. So why do we see them? So for a web page to run smoothly, we need 60 frames per second. And if we do little math, we find that it's 16 milliseconds per frame, which is too less. And since we know that JavaScript is single-threaded, so that single thread has to do painting and rendering of a UI, and it also has to do JavaScript execution. If JavaScript is complex and it's taking too long to run, then UI gets compromised. There's no one to render and paint UI, and that's then our UI becomes unresponsive, and we see that dialog. But the same JavaScript also gives you a solution, which is web workers. So this diagram shows how our main thread creates a worker thread, and then it communicates with that thread through messages, and then at the end, it can terminate the worker thread, or worker thread can terminate itself. So what exactly web worker is? It is a way of running JavaScript in the background and not interfering with the UI. And it can do anything that a regular JavaScript code can do. But like it can make AJAX calls to server, but there's something that it cannot do, which is it doesn't have access to DOM, it doesn't have access to window. So let's see a small demo. So this is a web page that I have created. You have blooming flowers, you have a link which you can click on, and you can enter a number. So let's see what JavaScript code is doing. It takes that number, it makes square of that number, and then it runs a for loop for that many number of times. It creates a result and sends it back to the web page. So right now we have our simple plain vanilla JavaScript, and let's give it a number. So you get the result. Now let's give it a big number. So now flowers are not blooming. You cannot click on the link and your UI is unresponsive. You can just sit and wait for JavaScript execution to get over, which is frustrating. And this is unresponsive UI, and this is when you get such dialogues. Okay, so now the JavaScript execution is over and you see the result. Let's see how this problem is solved by a web worker. So let's go ahead and comment the regular JavaScript code and uncomment the web worker code. Okay, on line 61, we can see that a worker thread is being created. And this is the code which runs in worker thread. So it's the same code, like number is being squared and then for loop is running and then result is created. So let's refresh it and see. So let's start with that same small number. You get the result. Not much change. But now let's give it a big number. You see that your flowers are still blooming. You can still click on the link. So this is responsive UI. This gives a good user experience. But JavaScript execution will take the same amount of time. Your web worker is not going to make JavaScript execution any faster, but it leaves main thread to work on UI. And that's why your UI doesn't get unresponsive. So let's see how it was working behind the scenes. So this is where main thread is creating worker thread using worker constructor. And now once worker thread is created, main thread is sending message to the worker thread using worker.postMessage, and it's sending the number to the worker thread. And here our worker thread is waiting for any message from the main thread by onMessage event handler. It takes that number and then squares it, runs the for loop, and now result is created. Now worker thread also wants to send back that result to the main thread. So it does it via post message. And here our main thread is also waiting for any message from the worker thread, which is worker.onMessage. Now it receives the message and it extracts data using event.data. At the end, worker thread can be terminated from main thread by worker.terminate or from the worker thread itself through self.close. So this was all about how web workers work. Now let's see how many types of web workers are there. There are two types of web workers, dedicated and shared. So dedicated is where a web worker has just one main thread, but shared web worker is where one web worker has several main threads and it communicates via port. Right, so let's see where are web workers today in JavaScript frameworks. Web workers are not new. They are around since 2009, 2010. But recently, JavaScript frameworks have started including them in their core code. Like Angular 2.0 already has web worker in their core code. And there's a team of engineers in Microsoft who's using React, and they are also doing some experiments in React applications using web workers. And they found that if they use web workers in React application, user experience is even better. There's a Redux library called Redux Worker that uses web workers. What they do is they put all the reducer code in the worker thread. So now this is the references. First two links are from where I got technical knowledge about web workers. Third link is YouTube link to the conference where Microsoft team is talking about their experiments with React and web workers. Fourth link is the YouTube link to conference where they are talking about their Redux library. Thank you. Hope you all enjoyed it.
That's a great example. Reminds me of the whole reason I got into web programming, which is when I saw a MySpace page where there was a butterfly flapping around, landing on my cursor. I don't remember that. I was like, that's when I knew I wanted to be in this field.
Nice. Yeah, what I love about it too is that people often talk about JavaScript as this toy language, and they sometimes point out, oh, you can't do parallel programming in JavaScript, but you absolutely can, which Surabhi proves here.
Yeah, that's crazy. Like seeing those three different contexts that we just saw. It's like, you know, JavaScript is everywhere, and it's kind of. A few years ago, people said that it was kind of derogatory, but now you see it is actually everywhere. Yeah. It's impressive.
Cool. Well, that's what we got today. I had a great time up here. I've loved working with these engineers since October over the last 5 months. And if you want to follow up with them or any of us, feel free to reach out. You can email hello@fullstackacademy. You can leave a comment on this Facebook live feed, or you can just check out fullstackacademy.com if you're curious about anything there. I hope you tune in next time. It'll be 7 weeks. We'll have our next remote cohorts demo day.
All right. Thanks so much. Thanks, everyone.
Take care.